Okay, good noon everyone, and welcome back to Data Structures Theory Sessions. In previous session, we looked at operations on simple queue. We have already seen few operations like init, insert, delete and all. And in previous session, we looked at few remaining operations like pick, change, display, is empty, is full, and so on. Now, once we complete that those operations on a simple queue, we've also gone for one example which actually tells you what are the limitations of simple queue. A simple queue, if you use it once, then you cannot reuse a simple queue again. Even you do have few empty elements at initial place or front or on the left side, still in simple queue you cannot use those elements. And to overcome those problems, what we do is we go for the circular queue. Now we have discussed how circular queue looks and how it works. So today we are going to have a look at operations on a simple circular queue now. Okay. So let's again have a look at what or how circular queue looks and how it works. Now in terms of memory, there is no change. You require one data array and you require two other variables, front and rear. So your structure is gonna be the same, just like simple queue. तो फिर वो circular की तरह behave क्यों करेगा? Now that depends on how we write those operations, insert, delete, display, change, those operations, right? So when we define those operations, we are going to make this simple array work like a circular array. जब हम operations लिखेंगे तब हम इस तरह से लिखेंगे कि ये एक normal array जो है वो कुछ circle की तरह behave करे, and that leads to the circular queue. So we discussed that look, a linear one is always going to be the simple forward manner, 0 1 2 3 4 5 6 7 8 and on. But if we want to have, let's say 0 1 2 3 4 and then back to 0, then we discussed that a modulo operation will help us. Modulo is nothing but reminder. So whenever you go for f++ r++, you are normally going for a forward direction. But then what you do is you limit it to your size. So modulo and then your maximum size will make it circular manner. So in terms of memory, it will be simple array like this one. But for us, it is going to look something like this one in a circle form. Okay. Now how it will be done? So let us focus on init operation. Insert operation. Look, init is same. Front and rear both are -1. Negative index. Queue khali hai. So init operation is same, no change. अब insert operation में थोड़ा बहुत change आएगा. Let's quickly find out what was the simple queue insert operation. Quickly tell me, what was the simple queue insert operation? We have to check overflow condition. If it is not full, then maybe in the else part, what you do is, if it is the first value, if your front is -1 and your rear is also -1, then you make front equals to rear equals to 0. Else you simply do r++, right? And then what you do is you store a value at a rear place and you are done. Look, this was the simple queue insert operation. And at the time of insert, what we for overflow condition, what do we check? If your rear is max -1. Now look, this was simple queue insert operation. Now we are going to make this work like circular queue. Now let us understand how circular queue works, and then we will also try to change this existing code as per our need. So if I say this is my circular queue with the same size 5, and initially my front is -1, rear is also -1. I have initialized it. Okay. So when we go for the first insert operation, let's say I want to insert 5. तो circular queue में start तो 0th position से ही होगा. So I want to insert 5 at this place. But at present my front and rear both are -1. So if it is -1, जहां से हम खड़े रहते हैं वहीं से लाइन शुरू होती है. मतलब पहला नंबर जब आएगा तो फ्रंट रियर दोनों को 0 करना पड़ेगा. So that code we do have already. If front -1, rear -1, then make front equals to rear equals to 0. So that much part of your code is perfect. मतलब इतना code जो है वो perfect है. Let it be. And if we execute that code, तो क्या हो जाएगा? Front becomes 0, rear becomes 0. So this is where your front and rear both are pointing to. So पहला insert operation कोई problem नहीं चलेगा. Okay, let it be as it is. Now we go for the next insert operation. I want to insert 6 and that goes on the next place. जब आपका rear update होके यहाँ पे आना चाहिए. तो चलो देखते हैं कि जो existing code है वो work करेगा. Now rear is 0 और existing code क्या करेगा? Else में जाके r++. So 0 becomes 1 and at index 1 we are going to store our new value. So still this works. तो इतना कोड अभी के लिए तो वर्क कर रहा है. फाइन, नो चेंज. अगर इतने टाइम में इसने वर्क कर लिया तो ठीक है. 7, 8, 9 भी वर्क करेगा. It is also gonna work. R++, it's okay. Fine. Now this current status of your circular queue says it is a full. It is full. And what is the current status? If your front is 0 and at the same time your rear is max -1, तो आप ये बोल सकते हो कि आपका circular queue full है. Now here comes the change. Only rear is max -1 is not enough. इसके साथ साथ फ्रंट 0 होना चाहिए, तभी आप बोल सकते हो कि आपका क्यू फुल है. सो वन चेंज इज हियर. फ्रंट इज 0 एंड योर रियर इज max -1. If this is the case, then we can say queue is full. So till now, no problem. अब मान लो कि किसी तरह से आपने कुछ डिलीट ऑपरेशन भी किया यहाँ पे. So you have deleted 5 and 6. Well, in that case, your front will be pointing to index 2. Okay? किसी तरह से हमने डिलीट किया है, तो this is gonna be your current status. So अगर 2 वैल्यू डिलीट की है, then your front will be 0. Your front will be 2. Now this status indicates you have 2 empty elements, and in this case your queue is not full. पहला कंडीशन देखो, rear तो max -1 है लेकिन front 0 नहीं है, so it is not full. So हम नीचे जाएंगे else part में. Front rear both -1, no, तो हम else में जाएंगे and r++. So if I want to insert a new value now, अगर मुझे 10 इंसर्ट करना हो तो ये एग्जिस्टिंग कोड जो है यहाँ पे प्रॉब्लम क्रिएट करेगा. बिकॉज एट प्रेजेंट r इज इक्वल्स टू 4. अगर मैं सिंपली r++ कर दूं तो वो 4 से 5 हो जाएगा एंड 5 इज नॉट अ वैलिड इंडेक्स फॉर मी. इट शुड बिकम व्हाट? 0. इट शुड बिकम 0. Right? So we have to make change at this place, and it is going to be r equals to r plus 1 modulo max. So at present your rear is 4. 4 plus 1 is 5. 5 modulo maximum is also 5. So 5 modulo 5 is 0. R becomes 0. R becomes 0. तो आप ये बोलोगे कि सर आर यू श्योर जीरोथ एलिमेंट खाली है, तभी ये चलेगा. वी आर श्योर zeroth element is empty because that condition we have already checked. So now what happens is your R will go to zeroth element and at that place you can store your new value. तो ये सर्कल मैनर में मॉड्यूलो वर्क कर गया, नॉर्मल लीनियर में मॉड्यूलो वर्क करेगा. लेट अस सी व्हाट इफ आई वांट टू इंसर्ट वन मोर एलिमेंट 11. अगर मुझे 11 इंसर्ट करना है तो क्या होगा? वेल फ्रंट 0 रियर मैक्स -1 नहीं है, which means Q is not full. So I'll go to else part. Front and rear both are -1. No. So I'll go to this else part. And I'm going to increase my rear by 1 and then I'll make modulo max. So what is your rear right now? What is your rear right now? It is 0. Index 0. So rear is 0. 0 plus 1 is 1. 1 modulo 5 is 1. So you will update your rear by 1. Okay. So it works and I can store 11 here. So this modulo operation works properly. R equals to R plus 1 modulo max. That works properly. Now this is another case. At present whatever you have in a queue, now this is another case where you say your queue is full. अभी जो आप देख रहे हो ये दूसरा एक केस मिला जहां पे आप बोलोगे कि आपकी क्यू फुल है. You don't have any empty space and that's the other case, which means ओवरफ्लो कंडीशन आपको एक तो मिला था और भी एक केस मिला जब आप ये बोल पाओगे कि भाई क्यू फुल है. इन दोनों में से कोई भी एक कंडीशन अगर बनता है तो फुल, मतलब these two conditions are going to be merged with or condition. Okay, and what is the current status now? What is the relation between front and rear? Front is exactly rear plus 1. Yes or no? If your front is exactly rear plus 1, तो आप ये बोल पाओगे कि अच्छा आपका क्यू फुल हो गया. So that's one more scenario where you say your queue becomes full. And this is the circular queue insert operation. So दो जगह पे मेजर चेंजेस. ओवरफ्लो कंडीशन बदल गया एंड जब हम इंसर्ट करते हैं तो रेयर अपडेट करने का जो कोड है वो बदल गया. सर्कुलर मैनर में लाने के लिए R++ तो करते हैं लेकिन विथ मॉड्यूलो मैक्स. फाइन. वेल इस एग्जाम्पल से आपको ये भी पता चल गया कि हाउ सर्कुलर क्यू वर्क्स. काफी सारे इंसर्ट ऑपरेशन करके हमने देख लिए यहाँ पे, राइट. 5 6 7 8 9 5 6 डिलीट होने के बाद 10 11 भी इंसर्ट हो गया. यस. R+1 तो थियो. 1 મોડ્યુલો 5 કરો તો રિમાઇન્ડર શું વધે? 1 મોડ્યુલો 5, 1 ડિવાઇડ બાય 5. 1 ને 5 થી ભાગો. ભાગાકારમાં નહીં સમજાય તો સ્કૂલમાં મોકલી દઈશ પાછું. 1 divided by 5 cannot be possible. એટલે 5 0 થી મલ્ટીપ્લાય કરશો એટલે 0. 1 minus 0 નીચે 1 રિમાઇન્ડર 1. ભાગફળ નથી જોઈતું, મને શેષ જોઈએ છે. ભાગફળ કહેવાય ને. હા, okay. Well, so let us see that algorithm here. Okay, whatever we have discussed, the same thing here in terms of in the format of algorithm. First, we always check overflow. Now, there are two different conditions for checking whether your queue is full or not. The first one is if your front is 0 and at the same time your rear is max minus 1. एक ये condition आ गया. Or the other case, if your front is exactly rear plus 1. So ये दो condition हो गए, दोनों में से कोई भी एक true है, then queue overflow and you return. अगर full नहीं है, then what we do, we always go for the first case. If it is the first value, you make front rear both 0. Otherwise, you go for the maximum modulo. So rear equals to rear plus 1 modulo max. Then you store your value and you are done. Okay. So that's the circular queue insert operation. Circular queue insert operation. Now that's how we insert. Then how do we delete? Delete में क्या change होगा? Let's recall delete algorithm first. सबसे पहले if condition to print underflow, right? Then what? If it is not underflow, then in the else part, what you do, you take a value from front always, so that at the end you return your value. But before you return, what you do is you update your front by 1. Now this was the simple queue. Simple queue में सिर्फ इतना ही था, F++. अगर modified queue है तो आप थोड़ा और चेक करते हो कि भाई लास्ट वैल्यू है तो फ्रंट रियर बोथ -1 होंगे and so on. But if it is not a modified one, simple queue is this only. Now with this thing, what was the underflow condition? If your front is -1 or if your front is greater than rear. In both these cases, what you say? Your queue is empty. Well, let's keep this aside and let us focus on the circular queue behavior now. So we'll focus on a circular queue and we will assume that we have few elements already inside the queue. So if this is a circular queue with size 5, and let us assume we have few elements inside the circular queue. We have few elements inside the queue. Well, in this case, your front will be at the first value and your rear will be at the last value. मान लो कि ये आपका current status है and you want to delete. You want to perform a delete operation on this given circular queue. So if we simply go through the code we have on the right side, front is -1, no. Front greater than rear, no. मतलब queue खाली तो नहीं है. Then we go to the else part and we take the first value, front value. तो मुझे क्या मिलेगा? 5. And then I'm going to increase my front plus plus. So front plus plus. So this code works till now. अभी तक कोई प्रॉब्लम नहीं है हमें. अगर ये नॉर्मल डिलीट हो गया तो आप 6, 7, 8 सब कुछ डिलीट कर पाओगे. लीनियर बैनर ही जाएगा अभी तो. So let's say you have deleted 6. कोई problem नहीं, same code will work. Now let us assume after deleting few elements from the front, we have inserted few elements, just like previous insert operation we have seen. 9, 10, 11. That's where your rear will be. Okay. Now let us consider this is the current status of circular queue. Front is -1. No. Front greater than rear. Yes. Well, in this case, आपका जो पुराना कोड है वो तो ये बोल देगा क्यू खाली है. It is not. That means we cannot have this condition for overflow. ये कंडीशन हम ओवरफ्लो के लिए रख नहीं पाएंगे यहाँ पे. Let us remove it. वो कंडीशन ओवरफ्लो वाला कंडीशन मैंने अभी के लिए निकाल दिया. We'll define how we can say it is underflow. हाँ, underflow के लिए हटा दिया. We will define it later how we can say it is underflow. Okay, so अगर वो कंडीशन नहीं है then we go further. Else में जाएंगे, we'll take the front value. So मुझे 7 मिल जाएगा. And then I'll go for front plus plus. तो अभी भी ये front plus plus तो वर्क कर रहा है. Okay. So likewise, I can also delete 8. भी डिलीट हो जाएगा, नो प्रॉब्लम. नाउ हाउ अबाउट 9? अगर मैं अब डिलीट करने जाता हूं तो क्या होगा? लेट अस सी. फ्रंट इज -1. नो. तो अंडरफ्लो तो नहीं है. विल गो टू एल्स पार्ट एंड विल टेक द फ्रंट वैल्यू. तो मैं 9 तो उठा लूंगा. बट देन इट गोज फॉर फ्रंट प्लस प्लस. फ्रंट इज 4. 4 प्लस प्लस विल बिकम 5. अब प्रॉब्लम आया. इट शुड बिकम 0. 4 के बाद 0 होना चाहिए. तो जो हमने इंसर्ट में किया था वही हम यहाँ पे कर सकते हैं. इंस्टीड ऑफ फ्रंट प्लस प्लस वी कैन से इट विल बी फ्रंट इक्वल्स टू फ्रंट प्लस 1 मॉड्यूलो मैक्स. सो दैट विल वर्क नाउ. फ्रंट 5 की जगह पे क्या हो जाएगा? 0. So we have deleted 9. Okay. अभी भी एक सर्कल खत्म करने के बाद भी ये कोड वर्क करेगा या नहीं? Let's check it out. So still I'll go for delete operation. I want to delete 10. So front is -1. No. तो underflow तो नहीं है. Else में जाके front value उठाओ. So 10 उठा लिया. And then go for f equals to f plus 1 modulo max. So f is 0 right now. 0 plus 1 is 1. 1 modulo max 1 modulo 5 is 1. तो आपका फ्रंट अपडेट होके चला जाएगा 1 पे. Now this is the last value inside your queue. अब लास्ट वैल्यू कहीं पे भी हो सकती है, but let's focus on this. When we say this is a last value, when your front and rear both are pointing to the same value. जब आपका फ्रंट रियर दोनों एक ही जगह पे पॉइंट करेगा तो आप बोलोगे दैट्स द लास्ट वैल्यू. एंड वो मॉडिफाइड सिंपल क्यू वाला जो फंडा था वो यहाँ पे लेके आएंगे. अगर ये लास्ट वैल्यू है और उसको आप डिलीट करते हो तो आप अपनी सर्कुलर क्यू को इनिशियल कंडीशन में लेके जाओ. मेक योर फ्रंट रियर -1. सो एट दिस प्लेस, now let us see, this is our current status and I'm going for delete. Front is -1. No. तो underflow तो नहीं हुआ. Else में जाके front value उठाओ. So I'll take 11. But उसके बाद मैं blindly f plus 1 modulo max नहीं करूंगा. यहां पे हम क्या करेंगे? We'll check if your front is equals to rear. तो ये लास्ट वैल्यू है, उसको डिलीट करने के बाद फ्रंट इक्वल्स टू रियर इक्वल्स टू -1. एल्स यू गो फॉर f plus 1 modulo max. सो एट दिस टाइम जब आप 11 डिलीट करोगे तो उसके बाद आप फ्रंट और रियर दोनों को -1 कर दोगे. and that makes underflow condition very easy. If your front is -1, then it is empty. If your front is -1, only then you can say your queue is circular queue is empty. Otherwise, कुछ ना कुछ तो रहेगा, and we'll take that value. Additionally, अगर आपको चाहिए तो आप rear -1 चेक कर सकते हो, but not necessary actually. अगर चाहिए तो कर सकते हो, जरूरी नहीं है. So that is what our delete operation on a circular queue. With example, we have tried to understand how it works and what should be the possible code for circular queue delete operation. Let us see the algorithm here. So if your front is -1, then you can say your queue is empty and you return. Otherwise, what you do, you take the front value and then you check whether it is last value or not. If your front and rear both are equal, then that is the last value, and if I delete it, I'll make front rear -1. Otherwise, I'll go for front +1 modulo max and I will return the value. So that is my circular queue delete. So we have seen circular queue insert and delete operation. Any query or question till now? This is important, okay? Circular queue is important compared to simple queue. Great. Well, if there is no query, then let's go further. How do we change? But before we go to change, I want to go for display operation. Okay. So let us go for display operation once. Circular display. Now when we go for display operation, we need to tackle two different cases. Let me show you those possibilities first, and then you'll understand why two different cases. This is our circular queue. One possibility is this one. Where your front is pointing to this place, your rear is pointing to this place. And the other possibility is this one. Your front is pointing to 3 and your rear is pointing to 1. Now I'm saying these two are different cases. Why? Because at this place your front is less than R, but here your front is greater than R. Why am I focusing on? I'm focusing on front and rear, because front and rear defines where is my queue. फ्रंट और रियर जो है वही डिफाइन करता है कि आपका क्यू कहाँ पे है, कहाँ से स्टार्ट हुआ, कहाँ पे खत्म हुआ. When you go for printing your queue, you will always start from front and you will end it on rear. अगर क्यू को प्रिंट करना है तो आप फ्रंट से लेके रियर तक चलोगे. तो normally if I want to write a loop, what I do is I'll say for I equals to front से start किया, I less than equals to rear, rear तक चलाऊंगा I plus plus, and what you can do is you can print your data of I. Simple. Now this will only work if your front is less than R, क्योंकि आपने एक linear loop लिखा है I plus plus. So यहाँ पे क्या होगा? What is your front? 1. So मैं 1 से start करके प्लस प्लस करूंगा तो 1 to 2, 2 to 3, 3 to 4, no problem, up to R में चला गया. एक linear loop चलेगा because front is less than R. But if I take the same loop here, तो क्या होगा? What is your front? 3. अब I plus plus अगर मैं करता हूं तो 3 से 4, 4 से 5, 5 से 6, 6 से 7. Actually ये loop एक भी बार नहीं चलेगा. What is your front? 3. What is your rear? What is your rear? 1. Check this condition. Is it true? तो ये वाला लूप जो है वो सेकंड केस में एक भी बार नहीं चलेगा. This is not going to work with my second scenario, and that's why we consider both these cases as a separate one. Loop is always linear. Loop is always linear. उसको आप सर्कल नहीं कर पाओगे वरना इनफाइनाइट हो जाएगा. Right? So in our second case, what we have to do is we have to write two different linear loops. We will start from front, I plus plus जाएंगे, print data of I. But this is only possible starting from front up to what? Up to max minus 1, या तो फिर less than max. Up to max minus 1, या तो फिर आप less than max लिख लो. So what you have done is you have covered this much part. इतना पार्ट आपने एक लूप से कवर किया, and then you are going to write a second loop for this second half of your queue. So what we'll do here, we'll write another loop for I equals to 0, because वो 0 से ही start होगा, but वो कहाँ तक जाएगा? I less than up to rear. So equals to R, I plus plus, print data of I. So when you go for display operation, you have to check what is the current status of front and rear. If front is less than rear, single loop, else double loop. Simple. एक if लिख लो. If front is less than rear, less than equals to भी लिख सकते हो, चलेगा. So what we have to do here, explicitly we have to say if your front is less than equals to rear, तो single loop चलेगा, else you go for the double loop. Right? Any doubt in this operation now? Any doubt in this operation? Well, this is going to help you in change operation also. Because when we change something, we have a position. From that position, we are about to calculate index. और जो index calculate करेंगे वो front से rear के बीच में होना चाहिए. तो फ्रंट और रियर की कंडीशन यही रहेगी. इफ योर फ्रंट इज लेस देन इक्वल्स टू r, then it's a single range. It is a single range. But if your front is greater than r, then you have two different ranges, front to max and 0 to rear. So when you calculate your index, and then after that when you go for validating that index, आपको ये दो केसेस अलग से चेक करने होंगे. अगर पहला केस है तो आप सिंपल कंडीशन लिख पाओगे, भाई इंडेक्स जो है वो फ्रंट से रियर के बीच में होना चाहिए. लेकिन अगर दूसरा केस है तो आपका इंडेक्स दो में से कहीं पे भी हो सकता है, फ्रंट टू मैक्स के बीच में या तो फिर 0 टू रियर के बीच में. So this thing you are going to cover in a change operation also. So now let's come back and see how can we perform change operation. And here in the change operation we are going to see how we can calculate the index. We are about to calculate index in both the cases, front less than equals to r and front greater than r. So it's gonna be something like this, or maybe like this. Indexes are fixed. Right? Indexes are fixed. And we want to calculate that IDX, index, based on a position. Now first tell me, what was the equation for simple Q? It was front plus position minus 1. Now this was the equation for simple Q. Now let us find whether this equation as it is works with circular Q or not. Let's find it out. Front is less than equals to rear, पहला वाला केस. एक्चुअली वो लीनियर की तरह ही हो गया, नो चेंज देयर, तो उसके लिए हमें कोई प्रॉब्लम नहीं होगा. पोजीशन 1, 2, 3 और 4, चार वैल्यू, चार पोजीशन है. पोजीशन इज इक्वल्स टू इंडेक्स इस केस में एट प्रेजेंट, मतलब बिकॉज 0th वैल्यू निकाल दी. सो विल दिस इक्वेशन वर्क प्रॉपरली? व्हाट इज योर फ्रंट? 1. मान लो कि थर्ड पोजीशन चेंज करना है. No problem, right? So in your first case this works properly, no problem with that. If your front is less than equals to r, तो ये same equation चलेगा, कोई problem नहीं है. Now how about second case? Second case में आपकी पोजीशन कुछ इस तरह से रहेगी, चार वैल्यू, चार पोजीशन. Value 7 is at a first place, position 1. Value 8 is at a second position, and so on. Value 9 is at a third position. So we are focusing on that now. What is your front? 3. Value of front will be index 3. And let us say we want to change the second position. So I'll pass POS as 2. Minus 1. 5 minus 1 is 4. It works. But let's say if I want to change third position, 3 plus 3 minus 1 is 5. 6 minus 1 is 5. लेकिन वो होना क्या चाहिए? 5 नहीं, वो 0 होना चाहिए. सर्कुलर मैनर. जब भी सर्कुलर मैनर चाहिए मॉड्यूलो कर लो. सो अब क्या हो जाएगा? 5 minus 1 is 5. 6 minus 1 is 5. 5 नहीं, वो 0 होना चाहिए. सर्कुलर मैनर. जब भी सर्कुलर मैनर चाहिए मॉड्यूलो कर लो. सो अब क्या हो जाएगा? 5 minus 1 is 5. 6 minus 1 is 5. 5 नहीं, वो 0 होना चाहिए. सर्कुलर मैनर. 0. So what we have changed, the same equation is going to work, just we are going to add modulo max here. जो इंडेक्स आप कैलकुलेट कर रहे हो वही इक्वेशन, बस लास्ट में उसको मैक्सिमम साइज से डिवाइड कर दो and take the remainder. So this is gonna be your index calculation equation, but now we have to validate this index. If your front is less than equals to rear है, at that time your index will be within the range of front and rear, right? But if your front is greater than rear, तो आपकी जो इंडेक्स है वो फ्रंट से लेके मैक्स या तो फिर 0 से लेके रेयर तक रहेगी. अगर आप -1 लेते हो तो इक्वल्स टू लिख पाओगे. So if your front is less than equals to rear and your index is within this range, तो ये हो गया हमारा पहला पार्ट. और if your front is greater than rear and at the same time if your index is from front to max or it is from 0 to rear, ये हो गया आपका सेकंड पार्ट. एंड क्लोज योर इफ. कंडीशन बड़ी है और होने ही वाली है. देयर इज नो वे यू कैन ऑप्टिमाइज दिस कंडीशन मोर. So the same two different cases that we have considered at the time of printing, right? If your front is less than equals to rear, then you have a single range. If your front is greater than rear, then you have two different ranges, from front to max and 0 to rear. And we want to check whether our index is in between these or not. याद रखना, ये जो मैंने लिखा है, it is only possible when we write manually or when we write algorithm. दो कंडीशन आप प्रोग्राम में मर्ज नहीं कर पाओगे. प्रोग्राम में अगर लिखना है तो इस तरह से नहीं लिख सकते. यू हैव टू राइट फ्रंट लेस देन इक्वल्स टू IDX एंड IDX लेस देन इक्वल्स टू मैक्स -1. तो प्रोग्राम तो और लंबा होगा, right? But this is what the condition we have to check. We have to validate our index. अगर इनमें से कोई भी condition true हो गया तो index valid है. Else we say invalid position. Well, so that's gonna be your change algorithm here. The same process you can check for underflow. Otherwise what you can do is you go for front plus pose -1. Additional part is modulo max. आपको मिल गया इंडेक्स. अब इंडेक्स मिलने के बाद आप उसकी वैलिडिटी चेक करोगे. If your front is less than equals to rear and at the same time if your calculated index is within the range of front to rear, तो इंडेक्स फ्रंट से इक्वल या ग्रेटर होना चाहिए एंड इंडेक्स rear से equal या less होना चाहिए. If this is the case, we update the value. Else if we go for the second case now. If your front is greater than rear, तो दो अलग अलग रेंज बन जाएंगे आपके. Index greater equals to front up to max, or your second range, index greater equals to 0 up to rear. Then also we update the value. So we have gone for else if later here. Last में else क्या बोलेगा? Invalid position and you return. So that's your change operation also. Insert और delete दोनों में आपने is full is empty देख लिया. If your front is -1, emptiness condition मिल गया. If your front is 0 at the same time rear is max -1, or your front is exactly rear +1, that's your overflow condition, so is full mil gaya. So now we can say that we have seen all possible operations on circular queue, which is init, insert, delete. अगर delete मिल गया तो front update मत करो, वो हो गया pick. ठीक है? Display, change, is full, is empty. All possible algorithms or processes we have discussed. Take away task. Practical number 6 in your practical list. Implement a circular queue with whatever size you want, it's okay. कैसे implement करोगे? Just like stack and a queue. Circular queue को भी आप एक abstract data type बनाओगे. And then you are going to write all those functions. अलग file बन गया आपका header. You include that header file in a menu driven program जिसका skeleton ready है. Print all the menu, go for switch case. Case के अंदर से आप particular function को call करोगे and it will demonstrate your circular queue. If you follow these algorithms, then it is easy to implement. And that's why algorithm मैंने लिखे हैं PPT में. बाकी process I am going for manual. पेन से लिखता हूँ, लेकिन algorithm मैंने PPT में आपको दे दिए हैं. So you can follow these algorithms and you can implement your code. We'll stop here for now. So आज हमने circular queue complete किया. In the next lecture, just to revise how circular queue works, we will have a set of operation process. जैसे ही हम simple queue में करते हैं वैसे ही circular queue में कुछ operation करके देखेंगे, and then we'll go for the double-ended queue in the next lecture. So that's all for today. Thank you everyone for being part of this session. I'll suggest that at least you revise this entire thing once. Thank you.